Inorganic components. Minerals. The primary inorganic constituents of soil derived from the weathering of rocks. These include silicates, carbonates, phosphates, and oxides of various metals. Ions, essential nutrients for plant growth such as calcium, magnesium, potassium, and sodium. Salts, formed from various combinations of cations and anions in the soil, contributing to soil salinity. Organic components. Humus, decomposed organic matter which improves soil structure, water retention, and nutrient availability. Plant residues. Undecomposed or partially decomposed remains of plants including leaves, stems, and roots. Microorganisms, bacteria, fungi, algae, and other microorganisms that decompose organic matter and contribute to nutrient cycling. Soil organic matter, or SOM, is a broader category that includes all organic components in the soil, contributing to soil fertility and structure. Biogeochemical cycles. The nitrogen cycle. Nitrogen fixation, conversion of atmospheric nitrogen or N2 into ammonia, NH3, by nitrogen-fixing bacteria and archaea. Nitrification, conversion of ammonia to nitrites NO2 and then to nitrates NO3 by nitrifying bacteria. Assimilation, uptake of ammonia, nitrites and nitrates by plants to synthesize organic nitrogen compounds. Ammonification, decomposition of organic nitrogen back into ammonia by decomposers. Denitrification, conversion of nitrates back to nitrogen gas by denitrifying bacteria, returning it to the atmosphere. The carbon cycle is the process through which carbon atoms travel from the atmosphere into organisms in the earth and then back into the atmosphere. It's a complex system, but essential for maintaining the balance of our ecosystem. Photosynthesis is the conversion of carbon dioxide from the atmosphere into organic carbon compounds by plants. This process is crucial for life on Earth as it provides the oxygen we breathe and the food we eat. Respiration is the release of carbon dioxide back into the atmosphere by plants, animals, and microorganisms as they metabolize organic carbon. This process is a key part of the carbon cycle, ensuring that carbon is continuously recycled and available for use by living organisms. Decomposition, breakdown of dead organic matter by decomposers, releasing carbon back into the soil and atmosphere. Combustion, burning of fossil fuels and biomass, releasing stored carbon as carbon dioxide. Carbon sequestration, long-term storage of carbon in soils, oceans, and geological formations. The phosphorus cycle. Weathering, the release of phosphate ions, or PO43, from rocks through weathering. Absorption, the uptake of phosphate ions by plants from the soil. Consumption, transfer of phosphorus through the food chain as animals consume plants and other animals. Decomposition, return of phosphorus to the soil through the decomposition of organic matter. Sedimentation, formation of phosphate-rich sediments in water bodies which may eventually become rock. Sulfur cycle. Mineralization, conversion of organic sulfur into inorganic forms such as sulfates by microorganisms. Assimilation, uptake of inorganic sulfur by plants and incorporation into organic molecules. Decomposition, release of sulfur from dead organic matter by decomposers. Oxidation, conversion of hydrogen sulfide or H2S and elemental sulfur to sulfates by sulfur-oxidizing bacteria. Reduction, conversion of sulfates back to hydrogen sulfide by sulfur-reducing bacteria in anaerobic conditions. These cycles are integral to maintaining the balance of essential elements in ecosystems and supporting life on Earth. Understanding them is crucial for environmental management and conservation.